Hello guys, so if you're watching this video, you're probably new to calculus, and one of the most fundamental things of calculus is taking derivatives, because we use it in Cal 1 and Cal 2 and Cal 3 in differential equations, in physics, statics, dynamics, engineering, etc. Right? So we have to know how to take a simple derivative, and the idea is very basic. So this formula may look a little bit confusing, but the idea is we want to read this formula to identify how to take a derivative. So every time you see u apostrophe right here, like you see an apostrophe here, it means u prime, and prime means derivative. So I'm just going to write that up here at the top. I'll write it over here on the side. So prime is equal to derivative, right? So derivative. So this will always be true. Anytime you see prime in calculus, it means derivative. So the idea is we're going to take the derivative of f of x, and we're going to call it f prime of x. Now, we haven't solved for it because we need to identify a couple things. We need to identify our exponents, and our exponent is equal to 1. Our exponent is equal to 2 in this case. So we're going to call it n, right? So n is equal to 2. So what's n minus 1? N minus 1 is equal to 1. So now we have a formula here where we simply plug in. So our f prime of x is equal to n. What's n? Is 2 times x. Our x is basically our function, 3x. And then our new exponent, our exponent does change because we're subtracting 1. So it would just be to the 1 power. And if we simplify this, 2 times 3 is equal to 6x to the 1 power, which is simply 6x. So that's how you take a derivative. So the idea is identify your exponents, move it to the front, multiply by the constant, and then subtract. Your new exponent will be n minus 1, and that will be your exponent for your derivative. So if you just wanted to do this a simple way, so you have 3x squared. So you want to do this a simple way, move the 2 in the front, and then don't forget to subtract by 1. So we would move 2 times 3, x, and then our new exponent would be 2 minus 1, which would be 1, which would give us 6x, right? So here we have a larger example, but it's the same concept. So let's identify our n, our exponent. So our exponent is equal to 7. Our exponent for our derivative, which will be n minus 1, is equal to 6. So now we simply plug it into this formula right here. So what's n? N is 7. To solve for f prime of x, which I'm going to put down here, we have n times the function, so 7 times 8x, and then n minus 1 is equal to 6. So what our n minus 1 is, we plug it up here. So it's equal to 6, and we simplify this. 8 times 7 is 56x to the 6. And this would be equal to our derivative. If you want to do it if you're the kind of person that likes to do things in your head, multiply, and don't forget to subtract 1. So this would be 7 times 8, x, 7 minus 1 is 6, which is still equal to the exact same thing, 56x to the 6th power. And that's how you take a simple derivative. So for practice, go ahead and do these problems on your own, applying these principles. Identify n minus 1, and then plug it into this formula right here. You have a constant, you have x, and your new exponent for your derivative will be minus your current exponent for your function f of x. So your new exponent should always be 1 less. If it's not, then you messed up right here. If don't forget to multiply these constants out. And that's basically the idea of how you take a simple derivative. So identify your n as your exponent, which is coming from right here. Identify n minus 1 for the exponent of your derivative, and then plug it into this formula right here. U prime is equal to n times x raised to the n minus 1. And that's how you take a derivative. Thank you guys for watching. I hope this was helpful. And if you're new to calculus, I have a whole playlist on everything you're going to do in calculus 1, 2, 3. So just go ahead and check out this channel. Thank you guys for watching.